and we'll start the slideshow from the current slide, which is a blank slide. Well, I guess we will. There we go. I think I already gave, maybe before Marcus came in, the one kind of minor announcement. Tomorrow, normally my office hours are 10:45 until 1:15. However, I've got to meet some people tomorrow at 11:15, and probably will be tied up with them until 1 o'clock. So there goes my office hours tomorrow. So if you need to see me today, or catch me right after my 10:45 class tomorrow, or right before my 1:15 class, because I will not have much more time in the office tomorrow. All right, any questions? Anything we've done so far? Okay. What we had done last time, and actually what I think I'll do is do a graph. Haven't done many of those this time, but let's do. The last time we did example 5, which found the area of a triangle and it gave 3 vertices. Okay? This time it says suppose the 3 points in example 5 had been on the same line. And this time we're going to use 0, 1. Whoops, let me change my colors. Okay, 0, 1, 2, 2, and 4, 3. Okay, that's not going to form much of a triangle, is it? Okay, this will be the line through those 3 points. Okay, well, what we did before, by the way, this is 0, 1, this is 2, 2, and this is 4, 3. What if we try to use the formula that we did last time for what the area of that triangle would be? Well, the area, remember, is plus or minus 1/2 the determinant formed by the 3 points. 0, 1, 1, 2, 2, 1, and 4, 3, 1. Okay? What does that produce? Now, I want you to tell me how you would proceed with the determinant. What would you use? First row. I like the idea. We're going to use the first row. 2 reasons. 1, it's got a 0. Well, so does the first column. The other numbers are smaller, so that should make it hopefully a little easier. Now, we don't even need to mess with the first entry, do we? 0 times whatever is going to be 0. So let's go to the second entry, and what is the sign of that position? That second entry. A negative sign, so that's going to be a -1 times the determinant of what's left. And what's the determinant of what's left? Did you say -2? Okay, -2. Perfect. Okay, and now let's move to, I'll erase what I've done so far. Okay, ooh, I lost my 2 there. Okay, we'll go to the third entry, and what's the sign of that entry? Positive, so that's going to be a +1 times, and what's the determinant of what's left here? -2 again. Okay, so what do we have? Plus or minus 1/2 times -1 times -2 is? -1 times -2 is? Say again? Oh, no, yeah, not yet. Don't do that yet. Just do this in the bracket. Okay, no, it's a +2. Oh, okay, I'm sorry, I can't hear. 2 -2, which is 0. So sure enough, we don't need that plus or minus 1/2 because the area of that trapezoid is 0. Okay, so no, we don't need that. And of course not. They're collinear points. They're dependent. So there's no, oh, perfect attendance today. We're all running a little late, but we're all here. Good. I had a hold up at the house this morning, not at the house, but couldn't get away at the time I needed to. And so I was running late. I got here late and nobody was here. So I went down to my office, and then Jonathan was here when I got back, and then the other three have come in. So kind of a bad day all the way around, but glad you're here. Okay, now, since we see that if these are not collinear points, we get the area of a triangle from this formula, right? If they are collinear, we get a determinant of 0. So therefore, let's not say, oh, boo hiss, we can't do an area with it, or something like that. Now we have a test for the collinear points in an xy plane. And here's what it is. I think I'll go to the next slide, and that's this one. 3 points, x1, y1. Now this is in a plane. Yes. What's that? I tried, but it just won't erase anymore. Let me try this cloth. I tried that earlier, and it still didn't do. I wish I could. Oh, look at that. It is good. I tried doing this with this cloth, and it wouldn't take it off. But it is doing a little better with that. Since I knew I was going to be running a little late, I called and asked them to come put a note, and she must have used a marker that was running out of ink. And when it runs out of ink, the solvent goes first, so the color goes down, but the solvent that makes it easy to erase doesn't. Is that better? Well, not perfect, but I guess I needed more elbow grease. I don't know what these cloths have on them, but I'll keep it closed up as well as I can, maybe make it last a little longer. Okay. So you got 3 points, x1, y1, x2, y2, and x3, y3. And if you wanted to determine if they're collinear, they are collinear if and only if, IFF, okay, the determinant of that same one we've been using, what would it be? X1, Y1, 1, x2, y2, 1, x3, y3, 1. If that determinant is 0, they are collinear. If and only if. Okay? So, we have a test for it. So the test for collinear points can be adapted to another use. Okay? So we started off with the area formula, which looks a lot like this. But that's good only if the determinant is not 0. If it is 0, that means the 3 points are collinear. So now we have a test for collinear, but guess what? This then can be adapted. When you are given 2 points in the xy plane, you can find an equation of a line passing through the 2 points this way. Okay? I think I'll go to a clean slide because it'll get a little messy if I try to write on this one. So an equation of a line passing through 2 distinct points, x1, y1, and x2, y2. Now we know how to do that, don't we? The point formula, you know, calculate the slope and stuff. Well, here's a little bit easier way than that. Okay? You got these two, you want an equation of a line. So what do? We do the determinant of. Now, here's the difference. Well, it really doesn't matter, but it makes it better here. The first row, just put x, y, 1. X and y are your variables, not points. And then the next 2 lines do your points. x1, y1, the coordinate pairs there 1, and x2, y2, 1, and set that determinant equal to 0, and you're guaranteed to give you an equation for the line. So let's do it. Again, I think I'll erase, and we'll do example 6. Find an equation of the line passing through these 2 points, 2, 4, and negative 1, 3. 2 distinct points. There's got to be one line that passes through there, one and only one line. What's the equation for it? Okay? You tell me what to do. Okay, determinant. I hope that's the little thing you're talking about. Okay. X, Y, 1. Second. 2, 4, 1. Negative 1, 3, 1. Okay? And set that equal to 0. And then work it out. Okay? Now, I think I'll choose the X first. All right, so I'll wipe out the X and the Y. What position is that? Positive position, so that's just going to be X times, and what determinant do we have here? 1. Okay, then I will erase this one and that, and do the Y. Okay. What position is that? A negative. So it's going to be minus y times, and what's the determinant here? Second? 3, you said? Yeah, 3. Times 3. Okay. But we still got one more to go. Don't forget to do the last one. Okay. We'll do the last position, which is a 1, positive, so that's plus 1, times, and what do we have here? 10, right? Okay, and that's equal to 0. Okay, let's clear parentheses, and what do we have? X minus 3y plus 10 equals 0. Or we could say x minus 3y is equal to negative 10, or if you want it in slope-intercept form, that would be 3y is equal to x plus 10, so y is equal to 1/3 x plus 10/3. That's not particularly a great form, but those are all ways you could do it. Now, let's go back in time to how we used to do that, say, in high school or whenever you did it earlier. What would be the way you'd find the equation for the line? Find the point slope. We got 2 points, we don't have a slope, so find me a slope. What would be the slope? Second? Okay. Okay. You're doing the change of y. 4 minus 3 is... Okay, yeah. Let's do it just giving the 2 points. You don't know this other stuff. Okay. How do you get the slope given 2 points? Say that one more time. Okay, what would that be? Okay, you want to do a negative 1 over. A little louder. You may have said it right. I can't hear. Negative 3, perfect, which is 1/3. Ding, ding, ding. Yes, we got that. Okay. And then what do we do once we get the slope? Oh, this is a long time passing, wasn't it? Yeah, point slope formula, which was y minus y1 is equal to m times x minus x1. Now, that's not that hard to remember, is it? Because if you started with dividing by here, you have y minus y1 over x minus x1, which is exactly what you use for the slope formula, except instead of 2, you just use x equals y, and that's equal to m, multiply both sides. So that's pretty easy. Now, you choose which point, I don't care. Which point you want to use. Either one. 2, 4. So that'll be y minus 4, right, is equal to 1/3 times, second, x minus 2, okay? Now let's see what that gives us. Y minus 4 is equal to 1/3 x minus 2/3, okay? Then let's add 4 to both sides, but how many thirds is 4? 12/3 plus 12/3, right? That's 4, isn't it? Okay. So let's do that. Those go away. Y is equal to 1/3 x plus 10/3. Ding, ding, ding. Same thing. I think this way is a little easier, don't you? Pretty simple to do. Okay? Don't have all those multiple steps in there. Just do it. Okay. Make sense? So it gives you the same answer. You're not responsible for the second one, except just to check your answer, and sure enough, we got it right. Okay, so x minus 3y is equal to -10. That's the way they like to write it. Of course, any one of those, this form, or that form would be perfectly correct answers. Any questions? Okay. Now, that was areas. You think we could do something similar with volumes? Okay. The formula for the area of a triangle in the plane has a straightforward generalization to the three-dimensional space, which is presented without proof, thank you very much, as follows: the volume of a tetrahedron. Now, do you know what a tetrahedron is? Does anyone know what tetra means? 4. Okay, and hedron basically means sides. So you got a 4-sided space figure. Here's a side, there's a side, there's a side, and here's a side. You know, so you got a triangle here, 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 and one at the bottom. Okay, it can be oriented in any way, but that's a tetrahedron. Okay, they can be varying lengths or whatever. That's a tetrahedron. 3 triangles, and then a triangle at the bottom. Okay, so the vertices of this tetrahedron are x1, y1, z1, x2, y2, z2. How many do you think we need? Tetra. 4, x3, y3, z3, and one more, x4, y4, z4. Okay? Now, we want to come up with the volume of a tetrahedron. So the volume is going to be, guess what? You still got to have that plus minus there, because the resulting determinant could be negative, and volumes are negative, so you got to have the plus or minus to get it back positive. But the coefficient's a little different. Rather than be 1 over 2, it's 1 over 6. Okay? Now, where would that come from? Here's a suggestion. 3 points. 3 minus 1 is 2. 2 factorial is 2. 4 points. 4 minus 1 is 3. 3 factorial is, you know what factorials is? Say again? Okay. Factorial, give me a number, any number besides 3. We use a 3. Say again? 5? Okay. Kick him out of the class, okay. 5. 5 factorial would be 5 times 4 times 3 times 2 times 1. That's what factorial is. And Emmanuel's going to write out for us what 500 factorial is and turn it in by the end of the class. Okay, no, okay. It's 500 times 499 times 498 times 497. He's got a long way to walk. Okay. Smart aleck. Okay. Second? 3 factorial is? 6. That's what I suggest. I don't know if this, I can't test it by going any larger because I don't live in 4 space. I don't know what it would be there. But we're going to stay here. And you multiply this by, what would you think the determinant of what matrix would you put there? X1, Y1, Z1, 1. X2, Y2, Z2, 1. X3, Y3, Z3, 1. X4, Y4, Z4, 1. Sure enough, that's going to be your volume of your tetrahedron. Okay? And you choose which sign you want to give you a positive volume. So let's do example 6. Okay? I've got to do this in 3 space, but I thought I would use as much as I can here. That will be my XY axis, my YZ axis. So I'll let this be Y, this be Z, and I'll let this be my X axis. This isn't a very good, a convenient orientation, but at least it's already drawn for me. Okay? Now what we're going to do is tick off, we got 1, 2, 3, 4, yeah, we got everything we need there, we need it here. So we'll do 1, 2, 3, 4. I think that's all I need. So the 4 points here, okay, let me write them down. Vertices are 0, 4, 1, 4, 0, 0, 3, 5, 2, and 2, 2, 5. Okay, we want the volume of the tetrahedron made by those 3. So the first one is 0 on X, 4 on Y, and 1 on Z. There's 1 point. 4, 0, 0, 4 on X, 0 on Y, and 0 on Z. That's that point. 3 on X, 5 on Y. So you got to count over 5. 1, 2, 3, 4, 5. So there's your 5, and then we go up 2. 1, 2. So there's your next point. These are not going to be very pretty, okay, at all. And then your last one is 2, 2, 5. 2 on X, 2 on Y, 1, 2, and 5 on Z. 1, 2, 3, 4, 5. Okay? So here's our tetrahedron. And then you've got a hidden line back here. Okay, that's your tetrahedron. One plane here, there's a triangle. Here's a triangle, there's a triangle on the back side of the triangle. So, kind of ugly in this orientation. The one in the book is a little nicer because that's an isometric. This one, I don't know what you call it, but I was just using what they gave me. Okay. So what do we do with it? What would be the volume of that tetrahedron? So soon we forget. Plus or minus 1/6 times the determinant of 0, 4, 1. Wait, 1. Yeah. 4, 0, 0. 1. 3, 5, 2, 1. And 2, 2, 5. 1. That determinant. Now, how are we going to find that determinant? What would be your recommendation? Help me. Earth to class, come in, please. Okay. How would you approach to get that determinant? Boo hiss, it's not a 3 by 3, is it? We're not in Kansas anymore, are we, Dorothy? Okay. So what would you choose? Huh? You tell me. Add the first 2 rows? Okay. Let's just choose either a row or a column and build from there. Second row has the most zeros in it. So we're going to use this. Not going to be as easy as it was, but it's going to do it. And we go from there. So let's start with the first column. Now, what's in our bullseye there? 4. What position is that? Negative. It's a negative position. So that determinant, so this volume, I'm going to start down here, I may not have room, plus or minus 1/6 times, and you would have a minus 4, and then you have a 3 by 3 determinant. Okay? Here's the big boo hiss. 4, 1, 1, 5, 2, 1, and 2, 5, 1. Okay? Now, no zeros there, so my suggestion on how to do this one is repeat the first 2 columns. Remember we did that? 4, 5, 2, and this really isn't a determinant anymore, this is just how you do it. 1, 2, 5. Okay? Now, we'll do that in a minute. I don't know. I'll put a determinant sign there, but it's not the same. And then we go where? Where do we go next? Don't need to do the zeros. So do the 1. You're going down that second row, right? And what position is that 1? Sign of what position? Is it negative? Plus, minus, plus, minus, plus. Okay? All right, so that's going to be a plus 1 times the determinant that's left over there. Now that determinant is 0, 4, 1, 3, 5, 2, and 2, 2, 5. Right? Now that one we can do without doing the expansion, because we got a 0 in it. So we'll come back and do that. So let's go over here. This volume is equal to plus or minus 1/6. Now, times a minus 4. Now let's do this determinant. Remember how we do this? Your diagonals downward are positive. And what's that product? Oh yeah, it's been a long time, right? Working all these homework problems, it's easy to escape the memory, right? What's that? 8. Next diagonal. Positive 2. Next diagonal. Plus 25. Now we're going to do our up diagonals. Yeah, we're going down is positive. Okay? Now we're going to do our ups. And just because it'll be easier to see, I'm going to erase these construction lines here, and let's do our ups. Since all these are positive, since we're in the positive side of x, y, and z, some of those could have been negative. They just happen not to be in this problem. But let's do it our up diagonals, okay? And this one's first one's going to be -4, -20, and -5. Okay. We'll come back and finish that in a minute. Let's go on and do the next one, +1. So it's going to be, I think I'll continue it here. Where you want to do on that one, that determinant over there? You tell me. It's a toss-up. I don't care. I care a little bit. First row is just as good as the first column, but I would definitely go for one of those. So let's do first row, okay? Now, you don't have to do anything with the 0. That's going to produce 0. So let's go to the second column and do this. What is the position of that 4? Negative. So that's going to be a -4 times the determinant of what's left. And what's that? A little louder? I can't hear. 11. Okay. It reminds me of a dumb YouTube video I've seen before and heard it recently again. Someone making fun of a Scottish accent. It was an elevator with a voice recognized, thing, and so the door is closed and it says, "This is a voice-activated elevator. Please indicate which floor you want to go to." And the Scottish guy said in a very heavy Scottish brogue, 11, or something like that, Scottish. And the voice comes on and said, "Please slow down and repeat your thing." And for the next, I don't know, it goes on for minutes after minute after minute. He keeps saying, 11, please repeat. Do not get upset. And he can't get out of the elevator because it doesn't recognize the Scottish brogue. That's beside the point. Okay, we've done the first one. Let's do this one. Okay. What's that? First, what position? It's a +1 times -4. Okay. So let's see what we've got. The volume is ±1/6 times. Now let's add what's in here first. Here we have a 25 minus 20 is 5, minus 5 is 0. Ha! I like that. And here's 8 plus 2 is 10, minus 4 is 6, minus 4 times 6 is minus 24. Okay? Follow? And then over here we have minus 44 minus 4, right? A lot of minuses. Let's add those together, and that gives you a minus 72. Is that right? Times, which are you going to use, plus or minus? Minus 1/6. And 1/6 of 72 is 12. Okay, there's your volume of that tetrahedron. Let's see what they got. 12. Okay, 12 cubic units, whatever those units are. Very nice. Okay. Now, what if, and this goes right with what we did before, what if, say, this point right here happened to be back on the same plane as that back plane? In other words, back here somewhere. So these 4 points don't form a tetrahedron, they're just defined plane. Guess what's going to happen then to that determinant? It's going to be 0 because there is no volume for that. So basically, you've just identified that those 4 points, rather than forming a spatial image, are all 4 in the same plane. Okay? So we have now a test for coplanar points in space. Let's go back here, and rather than, okay, I'm going to use a lot of what's here already. So here we have our 4 points. We won't count it as a volume. We really don't care about the plus or minus 1/6 because we're not determining the volume. But if that's the determinant of the 4 points, if these 4 points are coplanar, then that determinant is going to be 0. So that's how we tell those are coplanar if and only if this. So if when we go to do our stuff, we find out the determinant 0, we know all 4 of those points are on the same plane. They don't have to be on the same line. They could be, but we know they're in the same plane because the line is coplanar as well. Okay. The odds of being a line. Well, guess what? If that's the case, now we have another adaptation of this. If we have this being the case, then we can come up with an equation of a line, of a plane that passes through those points. And how would we do that? Get an equation of a plane. What are we going to need? Variables. So let's wipe out the ones here, make those our variables, and then now all we need are 3 points, okay? Because to make a plane, all you need is 3 points. So we'll rename those variables, not that it really matters. 1, 2, 3, I'm sorry. 1, 1, 1, 2, 2, 2, and 3, 3, 3. Okay, sorry about that. Okay. And set that equal to 0, and there you have equation of a plane. Now, if you remember in Cal 3, I believe it was late Cal 3, late Cal 2 or early Cal 3, somewhere in there, we did equations of a plane, and they were somewhat of a pain, but not too bad. But all you have to do is set it up this way. And it makes life so much easier. So let's do the example with that. Any questions before we do it? So let's do example 8. Find an equation of the plane passing through these 2 points. Do you want to go back to our thing? Let's do that. I don't know if passing through these 3 points. 0, 1, 0, -1, 3, 2, and -2, 0, 1. These are a little bit more of a pain to draw, but I think we can do it. So here's going to be our x-axis this way. Here's an x, this is y, this is z. That's the right-hand rule system. Here's our negative x going this way. Okay, this is negative x going that way. Of course, this is negative y, and this is negative z. Just to remind you. All right, let's plot these 3 points. How would I plot that first point? Right 1 and stay right there. 0 on x, 0 on z. Okay, 1 on y. Got it? Next one. Okay, I need to tick off some points here. 1, 2, 3, 4, 5, 6, 7. I don't need that many. Okay, and do some negatives here. Negative 1, 2, 4, 5, 6, 7, 8. Don't need that many, but we got it. Okay. Now we go -1 on x plus 3 on y. That would be 1, 2, 3 on y, and then up 2. Just don't say yours. Okay. So there's your point right there. Now this is on a two-dimensional graph. 3. So here's your first one, there's your second one, and your third one, minus 2 on x, and then 0 on y, and up 1 in z. So there's the third one. So here's the triangular shape, and that forms a plane. Now that's not the YZ plane, it's a plane doing something, some sort of orientation there. Sort of hard to see it on 2 dimensions, but that's a plane, okay? Didn't need to do that, but I did it. Okay, so what's the equation of that plane? How would you do that? The determinant of x, y, z1, 0, okay, and what do we do with it? Set it equal to 0. Exactly. All right. Now, how would you go about determining that determinant? Help me, help me. Do the what? First row? Oh yeah, I guess we have to almost, because that's the thing. I'm real tempted to do the second row. I think we'll still have everything like we want, but let's try the second row. I mean, most of the time, yeah, you would do that, but I think it'll still work out if you do the other. Let's try using the second row. They what do they do here? Okay. They tried to make it nicer, didn't they? And remember, with determinants, you can do that. Now, is that what you were doing before? Trying to, the last one, I didn't take a look at it to see if your suggestion was good, but sorry, I just sort of blew on past it. But let's see. You come awfully close, you have 2 zeros there. And they say, is there a way to get another 0? Okay? And there's a real easy one. Subtract this column from that column. Now, if you're doing row reduction, you can't do columns. But with determinants, you can. Okay? So let's do subtract this column from this. So column 2 minus column 3, and column 4 is the new column 2, I guess is what they did. Yeah. Okay? So, really need a little bit of room, so let's do it here. Okay? So, x, now the new row, column 2 is going to be 2 minus 4, so that's going to be y minus 1, z, and 1. Okay? The only one we're changing is the second column. The next is going to be 0, and 1 minus 1 is 0, 0, 1. The next one's minus 1. We're not changing that. 3 minus 1 is 2, 2, 1. And then the last one is negative 2, negative 1, 1, 1. Okay, we lost 1, 0, but we gained 1 where we really wanted it. Now we use that second row. We could have done it before, but this saves us a little bit, and we use that second row. Okay? And we'll use that 1 position there, and what's the sign of that position? That 1? This one? Positive, plus, minus, plus, minus, plus, okay? So that's going to be, that determinant is going to be, I'll come over here, 1 times that determinant you have there. I'm going to do it down here. X, y minus 1, z.
That's not negative.
What, the one there? Okay. Plus, minus, plus, minus, plus. Plus, minus, plus, minus, plus. Any way you got it. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, well, however you get there, it's going to be a plus. Right? Yeah, it is a plus. Okay. Okay. The determinant that's left is minus 1, 2, 2, and minus 2, minus 1, 1. Okay. Now, nothing easy to do here, so therefore I suggest that we expand the first two columns again. So that's going to be an x minus 1 minus 2 and a y minus 1, 2 minus 1. Okay? And let's do our diagonals. And this is going to give us our answer, isn't it? Okay? So what does this give us? This thing has got to equal 0. Remember, that's where we're heading. So what does this give us? Help me, help me. 2x. I think I'll write it over here. 2x. This one gives us, now we may have to do a little bit of work here. It's going to be a minus 4y, right? And then a plus 4, right? Because it's y minus 1 times a minus 4. So it would be a minus 4y plus 4. Okay? Our next down diagonal is going to give us plus z. Okay, now unfortunately we've got to do our up diagonals. I don't know if it's helpful to erase them, but I will. Okay. All right. Up diagonal here gives us, second, positive 4z, because up is negative and the negative 4z. Okay. The next one is going to give us a plus 2x, and our last one is going to give us minus 1. Okay, right? Plus y minus 1. Okay? And this thing is equal to 0. All right? What you think we're going to do next? Combine like terms. I see two x's in there. In fact, I see two 2x's. So that's 4x minus 3y plus 5z, and then second plus 3 equals 0. And you could write that as 4x minus 3y plus 5z is equal to negative 3. Either one of those is fine. Let's see what they got. 4x minus 3y plus 5z equal negative 3. Good for them. Okay? Now, getting close. There's a linear algebra applied here, which is really a very interesting one. Do you remember Kepler's first law of planetary motion? Probably not, maybe a little bit. All planets travel in ellipses, with the sun as one of the foci. And there's a equation you can do there, and then you can start doing the, I'll let you read it, but it's an application of that. It's really hairy because you got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, yeah, 6 row, 6 by 6 matrix with squares and cross products and all sorts of things there, but it's all doable. Okay? On a computer, much nicer doable. Okay? It's not something you want to do by hand. But anyway, there's an application, so you could write on linear algebra. Well, you've already done all your papers. So okay. Homework exercises 3.4. Any of the odds 1 through 7. Do number 9 if you can, worth a shot. Do number 11 if you can, worth a shot. Do either 13 or 15. 13 is an illustration, 15 is a proof, you choose. Any of the odds 17 through 29, either 31 or 33 or both. 35, 37 or 39 or both. 41 or 43 or both. 45 or 47 or both. 49 or 51 or both. 53 or 55 or both. 57 or 59 or both. 61, 63. And that finishes chapter 3 for good. There are review exercises. Odd number exercises there are also worked in calccheck.com, worked out solutions with for the odd numbered problems. So you can use any of those if you need more review there. And then there's a little project at the end. There's a cumulative test at the end. And then there's vector spaces. That's where we'll start on next week, Monday. Okay? What's that? Next week is your last week. So you, all 4 of you have your test, right? The third test. Okay? So try to have those into me sometime next week. And whatever we cover in vector spaces, that will be your final exam. Just covering that. It's going to be 2 days worth of material. So not going to be a lot. Going to be pretty easy. What's that? Okay, wait. Slap yourself. I think you're dreaming. So you need to wake up. All right. Oh, no. I get paid. You know, you pay my salary. I don't want to cheat you out of any of my your tuition dollars, right? All right. Good deal. We will see you next week. Have a